Hi girls, let's start a new lesson. We finished in the previous lesson, we finished and discussed about adding and subtracting polynomials. In this lesson, we are going to discuss about multiplying and factoring polynomial. Let's get started. So here we have our objective is multiply a monomial by a polynomial, and also we have to factor a monomial from polynomial. Let's see that. So here in the first problem, we need to multiply a monomial and a trinomial. So what we will gonna do, let's get started. So here it's like you are distributing this one for all the terms that you have inside and you will have between the multiplication. So since this term is stuck with all of them, that means you are going to distribute it for all of them. I mean, you will multiply this monomial by all the terms that you have inside. So let's do that. So the first one, negative x to the power 3, negative x to the power 3, negative x to the power 3. So I'm just preparing my, what will I gonna distribute? Now here I have, this term will be multiplied by the first one. So between them, negative x to the power 3 times 9x to the power 4 minus x to the power 3, that's what I distributed to this one, times, I will put parentheses, negative x 2 to the power, there is no space, so I'm going to erase this part, times negative 2 negative 2x 3, keep in your mind between the multiplication, plus, or sorry, minus x to the power 3 times the remaining thing that I have. Since between the multiplication between these two terms, I can just simplify them easily, and that's what we did in chapter 7. So let's work on that. So here we have, here they are same base, I'm going to add the powers. So here is the coefficient -1 times 9, so it's -9. -9, x to the power, I have the same base, add the power, 3 plus 7, x to the power 7. Here I have minus and multiplication, -1 times -2, it's +2, isn't it? So that is plus 2. Now I finished from my numbers. So these again, same base, add the powers. So that is x to the power 3 plus 3, so it is a 9. Then here we have minus 7, just change the order for them. You cannot calculate anything else, and that's to the power 3. That's it. So which one from these will be the correct answer? So which one from these will be the correct answer? Check this one. But here, look, the sign, the positive, so that is wrong. This is also wrong because here is a 12. They multiply the powers. They just want to confuse you. So be careful if you have multiple choice in Pearson test. It is always like that. So the only case that we need to multiply the power, if I have x, for example, to the power 2, all this to the power, for example, 4, in this case, I will multiply them. Not like this, x to the power 2 times beside it, this is dot x to the power 4. Here I will add the power, here I will multiply the power, and that's what we finished from the previous chapter. So here again, I just multiply this term, all the terms that I have, and then I will have a situation exactly the same thing that we learned in chapter 7. So that's what I did here. Again, this is also wrong. So the only correct answer, it is only this answer. So you can see the answer in the book, which is exactly same thing that I did, but I'm just going to show you in maybe more organized than my handwriting. So you will multiply what you have here. You will distribute it for all the terms that you have inside. That's what I did. Then do your calculation, -1, -1 and 9, which is -9, x to the power 3 plus 4, which is x to the power 7. I did it in shorter than these steps. Here is same thing, because the same base add the powers that you have between the multiplication. Let's do this one. Exactly same idea. Let's do it. I'm going to distribute this one for all the terms that I have. So that will be, let me write parentheses, maybe it will be more clear for you. So that will be 5n, 3n to the power 3 plus, why I put plus, 5n times, remember this is a multiplication, n to the power 2. Even if I have negative here, that means -1, no problem. So these two will be like 5 times -1, so no problem. Plus 5n times 8. Let's do our calculation. We can easily do our calculation. So here 5 times 3, 15. N and n same base, add their powers. So n to the power 4 plus, sorry, here 5 and -1, it will be minus 5. N to the power 3. 5 times 8 plus 40. N, that's it. I'm done. Like that, I'm done. Let me give you more exercises. I just want to make sure that you are okay with the idea. Again, distribute. So that will be -w to the power 2, w minus. It will be minus w to the power 2 times -15. So be careful with the sign. Always the sign need focus. It is not difficult for my students, definitely, but you need from you focus. So here the same base, add the powers. So that will be 3. Minus will be plus 15 w 2. This one, distribute for all the terms. If you feel that you are confident you can multiply in your mind, I don't have a problem if you directly say, okay, miss, 4 times 2, it is 8. Then I know x times x, which is x, they will be the same base, so this is x to the power 4. I don't have a problem if you don't want to write this step. So 4 times -7. 4 times -7, it's 28. I know that it's a 28. I don't want to write other than these steps. X and x to the power 2, so that is x to the power 3. I know these are the same base. I can add their powers. So this is 2 and here is 1, so it's x to the power 3. Plus, miss, I know that here the coefficient is 1 and here 4. So 4 times 1, it's a 4. So plus 4 x to the power 2. So I'm done like this. If you feel that you are confident you can write it like this immediately, I don't have a problem if you don't want to write it like this. I'm just writing it for you to make for you more explanation and to show you what is going on here. So remember between the multiplication. Remember again, between the multiplication. So distribute this one. So that will be 8 times 7 will be what? So that will be -56. Again, y to the power 3 and 2, 5, minus and minus, plus 8 times 4. It's what? 8 times 4, 32. Y to the power 4. Y, it's to the power 4. 8 to the power 3 and 1, it's to the power 4. Minus, minus, it will be plus. 8 times 1, it's 8. Y to the power 3. So that's the idea. The idea is really simple. Just try it and practice it. Even if you feel boring listening to me, I know sometimes the video very long, so try to put the video beside you and try to solve them alone and check your answer by yourself. So check your answer from my video. So here the opposite side. So you have b times 2b plus 11 times 2b. So that will be 2. Please don't say 3. Many students say 3. Here is multiplication. Please remember always that this will be once you distribute something like that. There is parentheses between the multiplication. So that is 2b squared plus 22b. That's it. So we did this question and we did these 3 questions down, which is enough for this problem. Now we need to factor. Now the opposite. Can you see this direction? Now we started to distribute to get this one. Now the opposite. I will give you this one. You need to go back and give me this one. You need to factor it and give me the monomial outside. You need to pull out the monomial. How can we do that? That means we need to find the greatest common factor. That is the greatest common factor. How can we find the greatest common factor? We learned before how to find the greatest common factor, for example, between, for example, if we have, for example, 16, we have, and let me tell you 8, what is the greatest common factor between them? So that is 2 times 2 times 2 times 2. So that's the prime factorization for 16. And this one, 2 times 2 times 2. So what is the greatest common factor? I'm going to take the repeating number. So I'm going to take 2 and 2. So greatest common factor 2, 2 and 2. So times 2. I will take the repeating numbers only. So times 2. So finally, the greatest common factor, 2 times 2 times 2, which is finally, it's 8. So this is the greatest common factor. Let's try to find it here. First of all, I will take term by term and then I will analyze it. So 5x to the power 3. I can rewrite this one into 5 times x times x times x, isn't it? Here is the power 3. I'm multiplying this x by itself 3 times. 5 is already prime number, so I'm done. I cannot factor it more. Now, let's see the next term. It's a 25x to the power 2. So here we have, that's equal to, I know that 25, it's 5 times 5. This is the prime factorization. So let me write always the multiplication as a dot, because I don't want you confused that the multiplication is times 5x times x times x, isn't it? So x to the power 2, it is repeated the multiplication 2 times because the power 2. Finally, we have 45x. So we just need to find the factorization for 45. So what is the factorization for 35? You just divide by 5, which is 9, then 3, 3, 3. So then 1. So the factorization for 45 is equals to, and I repeated this part in the previous chapter, 5 times 3 times 3 times x, which is, this is the remaining. I just replaced 45 by this factorization. Now, let's see what is the greatest common factor. So my greatest common factor, 5 here, and there is 5 here, and there is 5 here. All right. Now, x here, x here, x here. Is there anything in all of them? No. There is x here and there is x here, but there is no more x here. So the repeated terms or numbers or variable, this will be the greatest common factor. So the greatest common factor here for this polynomial will be 5 times x. So 5x. 5x. Why? Because 5 and x, it's repeated in all of them. Let's do one more problem. Let's do this one. Again, I'll try to factor one by one into prime factorization. So term by term. So 3x to the power 4. So that is equals to 3 already prime number. So I'm fine with the 3 times x times x times x times x 4 times. Then minus 9 x to the power 2, which is equals to negative 9. I can rewrite it into 3 times 3. Then this x will be x times x, which is repeating the addition. Finally, we have negative 12x, which is equals to, what is the prime factorization for a 12? I can divide it by 2. 2 is the prime. Then I will get 6. Then I will divide the 6 by 2 again. So I will get 3. So then I will divide by 3. And finally, it's a 1. So the prime factorization is, I will drop my negative 2 times 2 times 3 times x. Again, step 2, I will look at the repeated number. So what is the repeated number here? 3 and 3 and 3 in all of them. Just take 1 3. X and x and x. Just it's repeated in all of them. Is there anything else repeated in all of them? No. So that means the only thing that I have to take, the greatest common factor is equals to 3x. That's it. Let's do one more exercise, then we will move to problem 3. Because in a problem 3, depend on problem 2. We will find the greatest common factor, then we will write the remaining things. Let me tell you after I finish this one. So I'm going to do with you, let's do this one for example, a to the power 3. So that is equals to a times a times a 3 times 6a squared, which is equals to 2 times 3. Sorry, I'm not going to write the multiplication the multiplication like this to avoid confusing you. I don't want you to think that it is x. So 2 times 3 times a times a 2 times. Finally, we have minus 11a. So 11a, it's exactly the same. There is no more factorization for this one. I don't have any two numbers. When I multiply them, I will get 11. 11 already prime number. So that's a. So finally, what is the common factor between all of them? A only. Because a, it's repeated in all of them. Nothing else. So the greatest common factor for this polynomial is a, only a. Now let's see factoring out monomial. So once we find the greatest common factor, we will write, you can factor it out of the polynomial. I mean, in the first part, we had, for example, 4x, and then inside, for example, 3x to the power 2, for example, times, for example, 2, for example, x plus 7, for example. Can you see this side once you multiply all these and then get the result? The result is given this time. We need to have this. And this one will be the greatest common factor. Can you see this one? This will be your greatest common factor. Let's do that. Step 1, we will find the greatest common factor for the polynomial. Then I will show you directly what should we do. So 4x to the power 5, I can easily factor 4 because I know it's 2 times 2 and 2 times 2, these are prime numbers. Then I will repeat x 5 times. So x times x times x, which is 5 times. Okay, so negative 24 x to the power, which is equals to, now I will factor 24. If you don't know what is the factorization, just take it in corner. This is even number divided by 2, so which is 12. Divide this by 2, which is 6. Divide by 2, which is 3. Divide finally by 3, then 1. So the factorization is 2 times 2 times 2 times 3. Okay, now I'm done from the 24. I don't forget the negative. I should drop my negative. X, I will repeat the x's 3 times. Okay. Now, finally, we have 8x. So 8x, I can factor it out into 2 times 2 times 2 times x. So I will see the common between them. What is the common between them here? I have 2, 2, 2 in all of them. Again, I have another 2 this time in all of them. And I have x in all of them. So my greatest common factor is 2 times 2 times x, which is equals to 4x, isn't it? Now I did not finish because I need to factor out a monomial from this polynomial. How can I do that? So can you see the remaining thing from each term that I had? The remaining thing from this one here, the remaining x 4 times, which means x to the power 4. That's the remaining from the first one. The second term, the remaining is negative 2 times the 3, 6, x, so x to the power 2. So that's the remaining. The last one, the remaining is 2. Now you almost done. Take the greatest common factor that you have, then take the greatest common factor that you have, then open parentheses, put all these terms inside it. So x to the power 4, negative 6x squared plus 2. That's it. You are done. So which is exactly the same as this one. If you distribute this, you will go back to this one again. If you distribute you will get back to this one. So that's the meaning of factor it out. We are taking the opposite. We will see what is the thing that we can take it out. So once we distribute, we will get exactly the same as this one. Let me give you more problem. So that's what we did exactly for x inside to the power 4 minus 6x squared plus 2. So step by step, you will feel that this is very clear. So the first one, 9, term by term, x to the power 6. Try to factor it. I'm going to factor it. 9 is really easy to factor. So that is 3 times 3. Then I'll multiply x. I'll repeat it 6 times. So that is x times x times x times x times x times x 6 times. Then 15 x fourth to the power 4, 15 x to the power 4, that is equals to, if you cannot factor it directly in your mind, you just can factor it in a corner. So 15, the first digit here, or the first number that I have here, which is in the ones, it's 5. That means you have to divide it by 5. So that is a 3. Then once you divide again by 3, which is 1, I'm sure most of you don't need that for 15, but I did it because I want to show you what to do with this one, especially if you have big number. So 5 times 13. As I said, I don't want to write the multiplication like that. So times 3 times x times x times x times x 4 times. Okay, 12x squared. So finally we have 12x squared. So that is, I can factor it out into 3 times 2 times 2, right? Because if you multiply 3 times 2 times 2, you will get 12 times x times x. Now, I will see the common in all of them. What is the common in all of them? 3 in all of them. Great. I have x in all of them. One more x this time in all of them. Wonderful. So, my greatest common factor is 3 because it's on all of them. X times x. X times x, I can fix this one into 3x to the power 2. But I did not finish yet. What is the factored form of this one? Of this one. So that's mean they want you factor this one, not find only the greatest common factor. Okay, I will rewrite just the remaining from this one. So the remaining is a 3 and x to the power 4. The x is repeated 4 times. So the repeated, the remaining part, x to the 3x to the power 4. Now this one 5, which is equals to 5x to the power 2. From the last one, the remaining is only 2 times 2, which is equals to 4. That's the remaining. Take these as a polynomial, sum them all or add them all if you have all of them here positive. So just add them all and then put this outside. So let's rewrite it. So that will be 3x to the power 2, open parentheses, 3x to the power 4 plus 5x to the power 2 plus 4. That's all thing that you must do. Take the greatest common factor, put it outside, open parentheses, write the remaining things. That's the idea. The idea is really simple. Now, what is the factor written as the product of a polynomial with positive coefficient and a monomial? So I'm not going to solve this until I make sure that you are okay with the understanding from the first part. This one, I'm going to do or solve with you one more problem or two more problems. Let's do this one. So that's 5k to the power 3, which is equals to 5 already prime number. So that's a 5 times k times k times k. 20k squared. So that is equals to, how can I factor this out? So 20, you can start by 5 or 2, it's up to you. Finally, you will get the same result. If I start by 2, I will get 10. So then 2 again, I will get 5, then 5. So that is 1. If you say, Miss, why don't you start with 5? 5 also prime number. By 5, you will get 4. By 2, you will get 2, then 2, then 1, which is exactly the same. You have 2 2's and 1 5. You have 5 and 2 2. It's exactly the same. The order is okay according to commutative property of multiplication. So we have 5 times 2 times 2 times k times k. I'm going to repeat the k 2 times. The last term that I have, it's negative 15. So I'm going to, even the negative 15, I have to simplify it, or factor it. So negative 5 times 3. Now I'm going to take the only thing that same in all of them, only 5. So the greatest common factor for this polynomial is 3. I'm going to write the remaining thing. So the remaining thing here is k to the power 3. The remaining here for k to the power 2. The remaining from here, don't forget, negative 3. Now I will rewrite all this. So that will be 3 inside k to the power 3 plus 4k minus 3. So that's the idea. Just to try them, make sure that you try them and practice them. In the coming days, once you practice a lot for this one, you want to do all these steps. You will directly, from the first look, you will factor, okay, I can see here, for example, you will see, okay, x, which is the smallest one from them, the one that has the smallest power, I will take it out. So you will find it, you can easily directly see the greatest common factor and take it out without doing all these steps. But basically, the beginning, you need to make steps so you can find the greatest common factor and factor the polynomials that you have. Let's see this one. Here we have word problem. The word problem, the idea is really simple and easy. So let's see. If we have a helicopter here, and this helicopter landing pad or helipad is sometimes marked with a circle inside a square. So that's what we have here. We need to find the shaded part. How can we find the shaded part? Definitely we will find the area of the circle, then we will subtract it from the area of the square. So I know that the area of the square, I'm going to write here the area of the square, which means S, the area for the square. I know that it is side squared, right? That's what I learned before. I will take one side squared. So let me substitute. So the area for that is x to the power 2x, sorry, all this to the power 2. And I gave you similar example, I think, before. So I know that this is a power raised to another power. I can distribute my power. So that will be 2 to the power 2, x to the power 2. That is equals to 4x to the power 2. Now, what is the area? Let me write in red. What is the area for green? What is the area for the circle? You learned before that the area for the circle, which is pi r squared. So that is pi r squared. What is r here? R given, which is the radius. R given is X. So that is equals to pi R is X, then to the power 2. Now I can write my shaded area. What they said here, write your answer in factored form, which means I need to factor this one, the area. So what is the area for the shaded part? Which is equals to the big one, which is the square, 4x. Then I will minus from the area of the square, the area of the circle, pi x to the power 2. Okay, they don't want me write it like that and done. They just want me write also the factor form. So what is the factorization for them? Again, the first term is 4x. I can rewrite it to the power 2, sorry. So it's 2 times 2x times x. The other one, pi minus pi x squared. So that is equals to, keep pi as it is, x times x. All right, what is the remaining, what is the repeating thing between them? X and x, x and x, greatest common factor, x, which is equals to x squared. What is the remaining from here? 2. What is the remaining from here? Negative pi. So finally, the area of the shaded part, which is written as factor form, greatest common factor squared, inside the parentheses 2 minus pi. That's the answer, which is this one. Make sure that you try this kind of a question. It's very important. Let me give you more exercise. Let me solve with you, got it. The same problem. Suppose the side length of the square is 6x. So let me graph for you. I'm sorry, this is square. It must be all the side equivalent, but no problem. So that is 6x. And the radius of the circle, okay, let me graph for you. Circle, the circle here. The radius for the circle is 3x. The question, what is the factored form of the area for the shaded region? Definitely they mean exactly the same idea. Again, what is the area for the square? Area for S, which is the meaning of area of the square, which is side squared, the length of the side squared, which is 6x, all this to power 2, which means now I can directly do it because I'm sure 100% you know what to do with this one. 36x to the power 2. The area of the circle equals to pi r squared, which is equals to pi 3x to the power 2. Remember, here is different. They gave us here a coefficient. So that will be pi 3 to the power 2. It's 9. X to the power 2. Then finally, the area for the shaded region. The area for the shaded is the area of the square, sorry, minus the area of the circle. That's what we got here, which is a 3/6 x squared minus pi 9x squared. Miss from where? The negative, because I need only the area for the shaded region. So it's like you are taking this part out. You are cutting this circle and throw it. That's why from the big part. That's why you are minus them. But they need it in factored form. What is the factored form? Since they need that, I can just directly make my, you know, that 9, I will directly factor like this time. I will factor it in an easier way this time, because inshallah you are okay. And so that's 9 times 4. Why I did this? Because I saw 9 here. And this is x2 minus pi 9x2. So I have, that is x2 and 9, x2 and 9, that's common in all of them. Pull it out. So take it out, 9x2, open parentheses, the remaining from here, 4 minus pi, 4 minus pi. Definitely you can make exactly the same thing that I did. If you couldn't understand, please review my PowerPoint, my PowerPoint and my video many times. You can stop it, you can continue it, you can just see half of it and complete it later. It is up to you, but make sure that you practice. Let me give you more idea. Here you have a circular mirror is surrounded by a square metal frame. The radius of the mirror, so this picture is for this one. So let's graph what we have here. So if we have the circle mirror, I'm sorry for my drawing, and the radius is 5x. Okay, then the side length of the FEMAT frame is 15x. So you have also square frame. It's surrounded by, which is exactly the same thing that I did. The side length of the frame is 15x. What is the area of the frame? Write your answer. If here you have to focus. Because I'm saying what is the area for the frame, that means the frame here, this part, which is the shaded region, which is exactly same thing that I did. But I might ask you, for example, on the test, or you might see it in Pearson also test, what is the area of the mirror itself, which is this mirror. The mirror is the circular thing. But because they are asking me about this one, so let me show you what I should do. So the area for the square, or the area for the frame, which is, I will directly, I'm not writing the rule this time, so 15x, all this to the power 2. So that is 15 to the power 15 to the power 2, which is equals to 205, x to the power 2. Then the area of the circle is equals to 2 pi r. Sorry, not 2 pi r, pi r squared. Pi r squared. So that is pi r, which is 5x, all this to the power 2. So that is equals to pi 25 x to the power 2. Now, what is the area for the frame? The area for the frame, which is equals to the area of the square, which is 205 x to the power 2 minus pi 25 x2 to the power 2. Now you need to factor them out. So you can factor this one and factor this one. I can directly factor this one. I directly can factor this one into 25 times 9 minus pi 25 x2. I can see that this and this one is same. I can pull them out. So that will be 25 x to the power 2. Inside you will have 9 x squared, sorry, not x squared, the remaining is 9 only. The remaining only 9 minus pi minus pi. The other one, that's it. The other one, exactly the same idea, but if I find the yellow part, exactly same thing. This time, you need to find the area of the circle minus the area of the square, the opposite, because they need the yellow part. So that's the idea. You will use your knowledge and your understanding in the question. That's the end of this lesson. Good luck, girls. Bye. Enjoy it.